Welcome to Geometry Pre-AP. Today we're going to deal with Topic 2, Section 2, Conditional Statements. If you want to pause the video and write down some of this vocabulary, you can, but we'll have different places in the video where you can pause and get this information. Our essential understanding for today is you can describe some mathematical relationships using a variety of if-then statements. The study of if-then statements and truth values is the foundation for all reasoning. So we use logic and reasoning to prove things in geometry. It's also the basis for law and politicians and argumentation and stuff like that. So this is a big beginning for those people who might be thinking about going into those fields later on in life. So first thing, a few key concepts is a conditional statement is an if-then statement. So here we have our if-then statement. So if we go in here, I'm just going to highlight this for you. We've got a conditional statement, if-then statement, and so everything's based on symbol, and the symbols for the if-then statement is the if P, the P arrow Q, and so we read the hypothesis is the part after the if, it's the hypothesis, and the conclusion is the part after the then. So if P is our hypothesis, then Q is our conclusion. Okay. So, and there's a Venn diagram for that. We won't cover many Venn diagrams. Some schools do more of that. We don't. Okay, so this is where you have to pause and write all this information down. Okay, so pause the video, and when you're ready to get this written and get all written down, start the video back up again. Okay, so we start off with our conditional statement, which is an if-then statement. So if the measure of angle A is equal to 15 degrees, then angle A is acute angle. So that's our if P, then Q. Okay? And so we read that as if P, then Q. The converse is interchanging, and so if you look here, the Q switches with the P, so then if you look at the beginning one, we move the hypothesis and the conclusion and switch those. So if angle A is acute angle, then the measure of angle A is 15 degrees. And so we can see our wording right there, if Q, then P. The inverse is the negation of the hypothesis and conclusion. So it is the negation of the conditional statement. Okay. And so that means if measure of angle A is not 15 degrees, then angle A is not an acute angle. And this is the symbols we use for that one right there. So all right, and so then the contrapositive, which is this one, is the negation of the converse. That's a little bit hard to read, so I'll just underline it instead. So if not angle A, then the measure of angle A is not 15 degrees. So remember the order of these, okay? So if I do some writing here with our pens, these two go together. Conditional and converse go together, or conditional and inverse, and then converse and contrapositive go together. So this is, you could say this is the positive version, this is the negative version, this is the positive version, this is the negative version. Okay. And so you're going to need to be able to write a conditional, a converse, inverse, and contrapositive. You need to be able to write all of these. If you mix them up, that can cause a problem. Okay. Now the truth values. The conditional and the contrapositive are equivalent statements. So that means they're both true. And when they're both true, the converse and inverse are both false. So if your conditional is false, your contrapositive is false, and your converse and your inverse could be true. If the conditional and the converse, ooh, that's not good, converse, let me rewrite that. And the converse are both true, then this can be rewritten as a biconditional, and I will cover that probably at the end of the video. All right, biconditional statement. That's a very specific kind of thing where the conditional and converse are both true. That's usually true when we're writing definitions, because our definitions are our conditional and our converse should both be true. And that's how we know we have a good definition. All right, so identifying the hypothesis and conclusion. So what is the hypothesis and conclusion? If an animal is a robin, then the animal is a bird. So if we look at this, the hypothesis is everything after the if, and the conclusion is everything after the then. And so we can see here that the hypothesis is an animal is a robin, and the conclusion is the animal is a bird. So pause video and do these two down at the bottom. When you're ready to see the answer for number 1, start the video back again. Number 2 will be in your notes, and I'm going to be checking that one. The hypothesis for the number 1 is you are an American citizen. The conclusion is you have the right to vote. And so you should have the same thing done for number 2 there. That's why it has a star, so that I know I can check that one to make sure you have done your work. Okay, so writing a conditional statement. When you're going to write a conditional statement from a statement that's not an if-then form, then you have to convert the statement to an if-then form. And when you're doing that, you want to look at the statement and you want to look for basically your verb and stuff like that. So we have vertical angles share a vertex. So this is our hypothesis, and share our vertex is our conclusion. So therefore, when I'm going to write the if-then version of this, hypothesis is vertical angles, conclusion is share a vertex, and so therefore we have, if two angles are vertical, then they share a vertex. If you're not sure about this, take out this they and use the same verb or the same noun, which is two angles. So if two angles are vertical, then two angles share a vertex. By doing this, you won't mess up when you change a converse or stuff like that, where you mess up with your pronouns, and I will look for things like that. All right, so take a minute, pause the video, write both of these sayings in if-then form, and then start the video when you want to see the first one. Okay, so anyone who has never made a mistake has never tried anything new, by Albert Einstein. So if you never make a mistake, then you never tried, or you never tried anything new. So do the one down at the bottom. Remember, look for the hypothesis and conclusion. Look for the verb to help you with that. And then we'll check that one in class. Okay, so finding truth values, which is, remember we said the conditional is true, the contrapositive is true, but the converse and inverse isn't true. In order to prove something is false, you have to create what's called a counterexample. And so a counterexample is just some way where you show me that it is false, okay? And so that is important that you be able to point out a counterexample. So if a woman is Hungarian, then she is European, okay? So if we look at that, to show the conditional is true, show that every time the hypothesis is true, the conclusion is true. So we look, Hungary is a European nation. So Hungarians are all Europeans, therefore the conditional is true. Okay, let's look at B. If a number is divisible by 3, then it is odd. Well, let's see if we can play with that true. If you find one counterexample for this hypothesis is true, and the conclusion is false, then the truth value of the conditional is false. So think about a number that might be odd or even. In this case, we want to know if something's even that's divisible by 3. Well, 12 is an even number. It's divisible by 3. So therefore, 12 is divisible by 3, but is not odd, so the conditional is false. Okay, so it's just finding that counterexample to prove something's false. Just because you can't think of it doesn't always mean that something is always true. We have a hard time trying to find that counterexample sometimes. All right, so if the given statement is not an if-then form, rewrite it. Write the converse, the inverse, contrapositive of a given conditional statement. Determine the truth value of all 4 statements. All right, so pause the video, write the converse, the inverse, and contrapositive because it's already in a conditional statement. Okay, so pause the video and start up when you're ready to see the answers. Okay, so let's take a look at the answers. So first, let's look at the converse. So remember, switching the hypothesis and the conclusion. So if you play football, then you are a quarterback. That is the switching of the hypothesis and the conclusion. All right. Our next one, we'll just show them all, and then we'll delete this off also. So their inverse would be if you aren't a quarterback, then you don't play football. And our contrapositive would be if you don't play football, then you aren't a quarterback. So let's look at these real quick, and let's look at for the truth values. So if you play quarterback, then you play football. We know that's true. And if that's true, we know this is going to have to be true. So let's look at the converse. If you play football, then you are a quarterback. Well, that's not true. You can play football and play other positions, so that is false. You could be a linebacker and you're still playing football, but you're not a quarterback. And if you aren't a quarterback, then you don't play football. Well, if you're a linebacker, you play football. So remember, these are equivalent statements, so this one's going to be false also. Okay, so true, false, false, and true. All right. So here's yours to do. This one you're going to have to write in a conditional form. So make sure you get that in conditional form. So pause the video, do this problem. Okay, so just to help you out here also, I'll tell you what I'll do. I will give you the conditional statement to help you. If two lines that lie in the same plane, then the lines are coplanar. And from that, you should be able to write all the rest of yours. And I'm not going to give you a hint on this, but you can work on this one with your truth tables also. Okay? All right. So here's another one for you to do. So I've got two for you to practice on. And for this one, I will help you by underlying the hypothesis and the conclusion. So your hypothesis is the first part, your conclusion is the second part. So work on that to write all your other conditional statements. Your conditional, your converse, your inverse, and your contrapositive. Okay, so I'm going to give you a couple to do in your notes. All right, biconditional. A biconditional statement is if your P and Q and P are both true, then you have P if and only Q. So look here in this example, if a point is a midpoint. A point is a midpoint if and only if it divides a segment into two congruent segments. Okay. So a biconditional, you know when you write a definition, it has to be done in a biconditional term. If not, then there could be some falsehood to it, and therefore it would not be a good definition. And so most of the definitions I give you in class can be written as a conditional statement so that the conditional and the converse are both true. I tend to not give you if and only if statements because I'd rather you just know them as conditional and converse. So, writing a biconditional. What is the converse of the following conditional statement? If the converse is also true, rewrite the statement as biconditional. So if the sum of the measures of two angles is 180, then the two angles are supplementary. So if we look at that, the converse is if two angles are supplementary, then the sum of the measures of the two angles is 180. So these are both true statements. The conditional and the converse are both true. And if they're both true, we can take that and write that as a biconditional. So the converse is true. You can form a true biconditional by joining the true conditional and true converse together in if and only if. And this is what it would look like. Two angles are supplementary if and only if the sum of their measures of the two angles is 180. Okay. Now there are a few problems in your homework to work on as a biconditional. If you have some trouble, I wouldn't be too worried about it. I'm not going to test you on the biconditional, but I do want you to know that there is such thing as a biconditional. All right, so identifying a good definition, which is kind of part of a biconditional. So which of the following is a good definition? A, fish is an animal that swims. B, rectangles have four corners. C, giraffes are animals with very long necks. And a penny is a coin worth 1 cent. So pause the video, pick which one you want, A, B, C, or D. Make sure you can back it up and give a good reason for it. And then start the video back again when you're ready to hear the explanation for this. Okay, so now it's time to look at these answers. So first, a good definition is reversible, thus it will not have a counterexample. A whale is a counterexample for choice A. A fish is an animal that swims. So a whale is not a fish and it still swims, so that's not good. So that one's out. Okay, giraffes are animals with very long necks. Okay, well that's part C. So very long is not a very specific term, and so your idea of long and my idea of long might be two different things. Okay, so we don't want to look with words like that. That's kind of gets that one out. Part B, which was rectangles have four corners. Okay, what's a corner? You know, you know, we could be real specific about that. You could be real vague. Somebody may not know what a corner is, and so that's not necessarily a good definition, as opposed to saying like a right angle, which we have a definition for. So that one's out also. So and we look at D. A penny is a coin worth 1 cent. So if you have 1 cent, then you have a penny. So it kind of goes both ways. So this is actually the better idea. Okay, and so therefore choice D is our best version because it can go both ways. Everything's clearly defined. There's no vagueness in that. So D should have been the answer you picked. All right. And that wraps up the end of conditional statements. Make sure, again, you can write that conditional, converse, inverse, and contrapositive. Might be good to put those on flashcards to help you with that. And also remember the symbols. The symbols can help you. If P, then Q. If Q, then P. Not P, then not Q. And not Q, then not P. And so those can help you remember. So conditional, converse, inverse, contrapositive. Okay, so see you in class.